Question 18. So we're going to start like we did before. It's a good idea to go through and underline any main details that might help answer the question, particularly numbers. So we're just going to do that now. So we've underlined the main numbers and also the actual question: what is the heat of solution? The heat flow accompanying the dissolving of the salt in in joules per gram and in kilojoules per mole. So we'll start off by writing out our equation. Q equals M C delta T. And we'll make note of the main pieces of information that we had, which is M, the mass of the water's accepting the heat, is 125 grams. The initial temperature is 24.2 degrees C. The final temperature is 21.1 degrees C. The mass of the potassium bromide is equal to 10.5 grams. And the specific heat capacity of water, which we won't make note of here because we already know it. Okay, we're going to substitute these numbers in a second. So I've just shrunk my numbers and put them to the side so I can see them. So I'm going to substitute them in. So we're going to have 125 grams. It's important to keep the units just so we don't get mixed up here. Multiplied by 4.18 joules per gram per Kelvin. Multiplied by, okay, so the temperature has decreased. It's gone down, hence decreased, and it's gone down by a total of 3.1. So we're going to do minus 3.1. To be honest, the sign really isn't that important because we can decide at the end if this is an exothermic or an endothermic reaction. And we're actually talking about the quantity of energy, so it should be a positive number because we're just talking about how much. We're not talking about whether it's lost or gained. It's not asking for the energy change, it's just asking for the amount of energy. Okay, so I'm going to calculate this. And the answer is going to come out to be 1,620, rounding it up, joules. Now, the question asks for it per gram. We know we've got 10.5 grams. So we simply need to now divide this number by 10.5 so that we have the amount per gram of kBr. And that works out to be 154 joules. Part of the question asks for it to be expressed in kilojoules. So that's 1.6 kilojoules. And it says per mole. So moles equals mass divided by RAM. The RAM of kBr is around about 119. So we're going to have 10.5 divided by 119, which is 0.088. So that's the number of moles we have. So to get kilojoules per mole, that's the kilojoules. That's the number of moles, kilojoules per mole, kilojoules divided by mole. And we're going to end up with an answer of 18.2 kilojoules per mole.